Alright, so this one's about lesson number 4. So we're moving into chapter 1, lesson 4, which is all about ratio tables. So we've worked with multiples and factors. We've worked with ratios, we've worked with rates. Now we're working with the ratio tables themselves. So in the real world link, it says a punch recipe uses 1 container of soda and 3 containers of juice to make 1 batch of punch. So it says draw red counters to show the number of containers of soda and draw yellow counters to show the number of containers of juice to make 2 batches of punch. So if we go back up here and look, we use 1 container of soda and 3 containers of juice. So red counters, which we talked about the other day, we're just going to draw dots, is going to represent the number of sodas. So the sodas is just 1, so we're just going to do 1, but we're making 2 batches, so we have to double this. We're going to do 2. Okay, and then it says draw a yellow counter, so we're just going to draw circles to show the number of containers of juice. Well, 1 batch uses 3 containers. So if we're making 2, we're going to use 6. So now over here, we have 2 sodas, 6 juices. Okay, so then we're going to go on to the next one. It says draw red counters to show the number of containers of soda. So basically we did the same thing, but now we're doing 3 batches of punch. So if it's 1 of soda every batch, we're going to do 3. Okay, and then since it was 3 juices per batch, we're going to do 9. Okay, so we have 3 sodas, 9 juices. So it says find the ratio in simplest form of soda to juice needed for 1, 2, and 3 batches. So the ratio for 1 is 1 to 3. Or you could write it as 1 to 3. Or you could write it as 1, 2, 3. I prefer the fraction way. That's just going to come more handy because we're going to deal with a lot more fraction type ratios because we're going to be simplifying a lot. So we're just going to leave it like that. So 1/3, so we have 1 to 3, we have 2 to 6, and we have 3 to 9. What do you notice about these 3 numbers? Those 3 fractions. They're all equivalent is what they saw. They're not equal, but they all can go into each other. So these 2 can be simplified down to 1/3. This one, 1/3, can be multiplied by certain numbers to get to these. So we'll be dealing with that here shortly with a ratio table. So going on to the next page, page 40. Okay, we're going to jump right into equivalent ratios. All right, so the quantities in the opening activity can be organized into a table. This table is called a ratio table because the columns are filled with pairs of numbers that have the same ratio. So like the example from the first page. We have soda, we have 1, 2, 3. We have juice, 3, 6, 9. Well, if you look, 1 to 3, 2 to 6, 3 to 9, those all simplify down to 1 to 3. That means they are equivalent ratios because they express the same relationship between quantities. So when you can simplify it down and they have the same thing when they simplify, that means they're equivalent. So we'll be talking about that here in example number 1. So, to make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much yellow food coloring should you mix with 5 cups of white icing? So basically what you're doing is you're setting the table up. So we have drops of yellow, we have cups of icing. So 6 drops of yellow for every 1 cup of icing. Well, if we're trying to do 5 cups of icing, we're going to multiply that by 5. Well, now we have 5 cups. Well, whatever you do to the cups of icing, you got to do the same for the drops of yellow. So you got to multiply this by 5. So it becomes 30. So it's going to take 30 drops of yellow food coloring to 5 cups of icing. And that's what the recipe calls for. Okay, same thing for number 2. So in a recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. If he ate at a constant rate, determine how many hot dogs he ate every 2 minutes. So this time, we have to work our way down. Okay, so we started at 66 hot dogs in 12 minutes. Okay, we have to get our way down to 2. But we have a ratio table, we have to fill this in. So we're going to start off by dividing by 2. Well, you get 33. Divide that by 2. You get 6. So how do you get from 6 to 2? Well, you gotta divide by 3. You gotta do the same thing up here. So you get 11, so basically for every 2 minutes, he ate about 11 hot dogs. All right, so we're gonna skip A and B for now. We're gonna go a couple pages. And we're gonna work on the guided practice. We're gonna work on page 42 this time. So number 1, okay, Santiago receives an allowance of $7 every week. How much does he receive after 4 weeks? Okay, in this ratio table, there are 2 empty boxes. Okay, they don't want you just to automatically skip to 4. They want you to fill in a ratio table. They want you to get used to using equivalent ratios. That's why we're doing this. Okay, so basically all you have to do is just, we're gonna multiply, we're just gonna basically go down the weeks. So 1 week, 2 weeks, 3 weeks. Okay, so how did we get from 1 week to 2 weeks? Well, we're basically gonna double this, so $14. And then in 3 weeks, if you get $7 per week, we do 7 times 3. Well, that would be 21. And then after 4 weeks, you would have $28. So you're either just multiplying, dividing, adding, or subtracting. That's how ratio tables work. Okay, you're just doing basic operations. So like this one. Tanya runs 8 kilometers in 60 minutes. At this rate, how long would it take her to run 2 kilometers? So we're not finding how many kilometers she ran, we're finding how long it took her to run the 2 kilometers. So we went from 8 to 2, but we're missing a piece of information. So so you need to come up with a good number, right, a factor of both 8 and 2. Well, that'd be 4. So how do we get from 8 to 4? Well, we divide by 2. Well, whatever you do at the top, you gotta do the bottom. So 60 divided by 2 would be 30. Okay, so how do you get from 4 to 2 now? Well, once again, you divide by 2. So you gotta do the same thing down here. So 30 divided by 2. So that means after 2 kilometers, it took her 15 minutes to run 2 kilometers. So it took her 15 minutes to do 2 kilometers. So guys, all you're doing is trying to just fill in this ratio table. That is the goal of the ratio tables. You're just trying to put the information in there so it makes it easier on you. So now you're gonna go back, and I want you to go back to page 40, and I want you to do A and B. So you're filling out these ratio tables completely, and then solving it for whatever it's asking at the end. So go ahead and pause the video and do A and B. Okay, now that you've done A and B, we're gonna go through them together. So A says a patient receives 1 liter of IV fluids every 8 hours, which they've already filled in for you. 1 liter of IV fluids, 8 hours. At this rate, how many hours will it take to receive 4 liters of IV fluid? So how do we get from 1 to 4? Okay, that's what you have to determine. Well, we want 1 to 4 by multiplying by 4. So we gotta do the same thing down here. So 8 times 4 would be 32. So it took them 32 hours to get 4 liters of IV. So that's how you would write that. That would be your answer there, 32 hours. And you have to fill in the ratio table as well. You have to do both. Okay, letter B says to make cranberry jam, you need 12 cups of sugar. So they already filled that in. Okay, for every 16 cups of cranberries. So we have that. So it says find the amount of sugar needed for 4 cups of cranberries. So we're going from 16 to 4. But we gotta find a good number in between so we can fill this ratio table in. Okay, it could be any multiple or factor since we're dividing. So in this case, since we're going from 16 to 4, a good number that's in between those that both go into would be 8. So how do we get from 16 to 8? Well, we divide it by 2. We gotta do the same thing up here. So 12 divided by 2 would be 6. Now, how do you get from 8 to 4? Well, you divide by 2 again. So we're gonna get 3. So this means that for every 4 cups of cranberries, there's 3 cups of sugar. 3 cups of sugar. So all you're doing with this is either multiplying or dividing. That's what you have to decide. You gotta find numbers that fit into those specific ratio tables. Since we started with 12 and 16, and we went from 16 to 4, 8 is a good number that we can work with. So those are things you gotta find, and those are the numbers you gotta look for. Ones that work with the numbers that are in the ratio table to begin with. So now we're going to go on to the next part of this. The next part of this is all about scaling. So multiplying or dividing two related quantities by the same number is called scaling. Okay, we kind of already did that a little bit in the ratio table, but we're going to go more in depth here with a real life problem. So cans of corn are on sale for 10 cans for $4. They want you to find the cost of 15 cans. Well, they've already filled in our first part here, so we have 10 cans of corn and $4. So we gotta go from 10 to 15. So you gotta find a number here that it goes into both 10 and 15. It's a little bit different than what we started with. Well, a good number that goes into 10 and 15 is 5. It's its own factor. Okay, so how did we get from 10 to 5? Well, we divided by 2. So we gotta do the same thing here. So 4 divided by 2 would be 2. Now, we're doing something different because we have to go from 5 to 15. Okay, so how did we get from 5 to 15? Well, we multiplied by 3. And whatever you do up here, you gotta do down here. So we're gonna do 2 times 3. So it would be 6. So 15 cans of corn will cost $6. That's how you would answer that. You fill in your table, and then you answer it out. You explain what it means. So just like example number 4 here. So Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? So, is there a whole number by which you can multiply 14 to get 49? Yes. Okay. So, yes, sir. No, sorry, I was thinking of 7. 14 and 49 do not work together. Sorry, that was my mistake. No, there's not. I was thinking 7 for some reason. 7 times 7 equals 49. 14 does not go in 49. So we're gonna have to scale back to 7 because, like I just said, 7 works, and then scale forward to 49. Okay, that's what it means to scale. You're either multiplying or dividing. Okay, so in number of hours we started with 14. Number of lawns we started with 8. Okay, we have to get to 49 hours from 14. Well, the way to do that, we got to find a number that works for both numbers. Well, we said 7, so we're going to scale back. We're going to divide. So we're dividing by 2, so we get 7. Well, whatever you do at the top, you got to do the bottom. So 8 divided by 2 would be 4. Now, we have to get from 7 to 49. So to do that, we have to scale forward. So we got to multiply. So 7 times 7 gets you 49. Well, whatever you do up here, you got to do down here. So 4 times 7 is 28. So he can mow 28 lawns in 49 hours. Okay, that's what we needed to find. Okay, we had to scale back and then scale forward a little bit. So let's jump over to the next page again. We're going to do a couple more examples. Okay, so number 3 here. It says Lamika buys 12 packs of juice boxes that are on sale and pays a total of $48. So before we even do anything, let's fill in our ratio table here. Okay, so we have 12 packs of juice boxes. So, yes, 12. I read that weird. Okay, and the price is $48. Okay, so we have to figure out how we're going to get to the next part here. So the next part says, use a ratio table to determine how much Lamika will pay to buy 8 more packs of juice boxes at the same store. Okay, so we have 12 and 48, so we got to somehow get to 8 packs. So we're going from 12 to 8. Clearly, you cannot just divide or multiply anything to get from 12 to 8. Okay, we have to come up with a number that works for both of them. Okay, a good number that works for 12 and 8, that's a factor of both of them, would be 4. Okay, because we can scale back. We can divide 12 by 3. Okay, so whatever we do at the bottom, we got to do the top. So 48 divided by 3 would be 16. Now, we have to scale forward. We got to multiply by 2. We got to go from 4 to 8. So we're going to multiply by 2. So 16 times 2, because whatever we do at the top, we got to do the bottom, would be 32. So 8 more packs, or 8 more juice boxes, or packs of juice boxes, is going to cost her $32. more dollars. $32 more. Okay? So, now let's go back, and I want you guys to do letter C on your own. Okay? I want you to do letter C on your own. So, read through it, and then you're going to fill this in. Remember, there's no way you can go from 25 to 105. It doesn't work together. There's not one number you can multiply or divide by to get from 25 to 105. So we got to find a number that works for both of them. So go ahead and pause it, and then do letter C and come back, and we'll go through it together. Okay, now that you're back, let's do letter C. So a child's height measures 105 centimeters, okay? So that's where we want to go. It says estimate her height in inches. So we're going from centimeters to inches. Well, they already set up the ratio table for you. So what we have to do is find a number that works for 25 and 105. So a good factor, a good number for that would be 5. So we gotta get from 25 to 5. To do that, you divide by 5. So I'll do the same thing down here. Okay, divide by 5. So you get 2. Okay, now we gotta go from 105, or 5 to 105. So you're gonna multiply that out. Okay, so we gotta multiply by 21. Well, 2 times 21 is 42. So her height in inches is 42 inches. Okay, so when you're scaling like this using a ratio table, all you're doing is finding a number that works from this first number to the second number. That's how you gotta do it. And whatever you do to the top, you gotta do the bottom. And vice versa, whatever you do to the bottom, you gotta do the top. Okay, so let's look at these again. Okay, so number one, when you're just working with a ratio table, you're just finding a pattern that's going over and over and over again. So like this case, he made $7 every week. So each week he's making $7 more. So it's basically doubling or not doubling, but it's adding 7 each week. Okay, so that's what you gotta find. Now here was where we had to scale. So we just divided it out. Okay, we went down the line. Okay, we went from 8 to 2, so we had to divide it all the way down. First one was multiplication, this one's addition, or division, sorry. Okay, and then you did the scaling. So at the very top, okay, on her vacation, Leah exchanged $50 American to receive $60 Canadian. It says use your ratio table to find out how many Canadian dollars she would receive for $20. So we're scaling again here because we're starting with $60 Canadian, $50 American. Okay, and we want to know how much she's going to get for $20. So you got to find a number that works for 50 and 20. Well, 5 works. It's a good factor for both of them. So we divide by 10, and we divide by 10, so we get 6 now. And then we got to go from 5 to 20, so we got to multiply by 4. So whatever you do the bottom, you got to do the top. So 6 times 4, 24. So for $20 American, she's getting $24 Canadian. Okay? And you guys could have done a different number here too. I'm not saying there's one set number. You could have done, so since I'll set up another ratio table. Maybe. Don't really know what's going on with my board. No idea. Okay, so basically, if you could put 10 in here. Okay, we could have done 10. So if you do 10 in here, 50 divided by 5 gets you 10. Well, you gotta do the same thing up here. 60 divided by 5, okay, that would be 12. So then, how do you get from 10 to 20? Well, you multiply by 2. Well, 12 times 2 is 24. No matter what, if you use a factor for these numbers, it will work. It does not matter which one it is. Like I said, you could have done 5, you could have done 10, and there's a few other ones you could do too. It just depends what's easiest for you. If you find a number that works, use it. Not everyone's gonna have the same numbers, okay? So then you're gonna work on the IXLs after this. They'll be posted, and I also star them. So if you look, all the ones that are starred are the ones that are due this week, okay? And also next week, once again, we're gonna be meeting from on Tuesday from 9 to 10 and Friday from 9 to 10, where you guys can come in and ask questions. Okay, if you guys have any issues with any of these examples, that's a good time to ask questions. So we can go through them, like, because we have all these extra problems in the book that you guys could be working on, like this independent practice. We didn't do any of that today. So you guys can work on this. This is just extra practice for you, okay? So this is all about ratio tables.